This second example now is looking at the hypothesis testing, chi-square, testing for equality of several proportion. What I will ask for us to do is to take 5 minutes maybe, read and understand this question, then we'll come back to it in order to solve it. Welcome back. After reading, we can first of all just determine the management question, or what we are being asked here in this scenario. From what I understand, the management question is trying to find out if the proportion of, I'll just write LC, loyalty card customers per store is the same across the three retail outlets. So this is what we are testing at 10% significance level. Therefore, the variable that we have two categorical random variable, namely one is the loyalty card membership. So loyalty card membership, and then our second one is the retail outlet. All these has been grouped into three, and this one is a 2, so we have a yes and a no, and this one we have Canal Walk, Santon, and Somerset Mall. Now let's move into our first step, which is defining the null and alternative hypothesis. For our first step, let's write it down maybe. Step 1, define null and alternative hypothesis. Let's just call our data. So proportion 1, proportion 2, and proportion 3 will be equal to the following. So 1 will be, I'll just write population proportion of loyalty card member at Canal Walk store, and this should be now just same thing but for the Santon Mall, and the last one also same thing but now just for the Somerset Mall. Okay, then in that scenario, what we would say for our now will be that 1 is equal to 2 is equal to 3, meaning that they are equal across all stores. Okay, my alternative now will tell me the opposite, or what I'll say, at least one population proportion is different. All right, let's now move on to our second step, which is to determine the region of acceptance of the null hypothesis. To determine the region of acceptance, in case you forgot, remember here for independence and equality, our degree of freedom is row minus 1 times column minus 1. Okay, so well, for this scenario, we are going to plot those one. We know that our row here we have 2, column 3, and therefore our degree of freedom will be equal to 2. Now, because we have a degree of freedom of 2 and we have alpha, which is equal to 0.10 because it's 10%, we are just going to go to our table with 2 and 0.10. It's just straight right in front of us here. So it's this value here. Then this is how I'm going to write my chi-square limit. My chi-square limit is then equal to one-sided upper tail always, so 4605. Then I will accept the null if the chi-square stat is less than this value, and I'm going to reject if chi-square is actually above this value. Okay, below, if it falls below or at this limit, and we reject if it falls above. Now let's go to our fun stuff where we're going to look at the calculation of the sample test statistic. Alright, as you remember, the first thing that we need to do is to work out our expected frequency. I'll begin by just rewriting my total because those will not change. And from there, I'll just apply this formula here where we know we take the ith row total times the jth column total, we divide by the sample size. I'm just going to work that one quickly. Let's say for yes in Connor, what I'm going to do, if I say yes, the loyalty card is there, and for Connor work, what I'm going to quickly do is I'm going to take 106 times 52, I'll divide by 180, and I'm going to get 30.6. If I do the same thing with no and Cano, then I'm going to have 74 times 52 divided by 180, which is equal to 21.4, and I'm going to write those here. And at this moment I'm going to pause the video. Feel free to pause and do that as well, then we'll meet here when everything is complete. Welcome back. Just check your values, make sure that you got the same value as I did just now. And now that we've worked our expected, so we have everything to jump on this table. So the first thing that you need to do, just rewrite down all your observed value and also put the expected value here. Then you know what to do. You just do observed minus expected, you square that, and you take the observed minus expected here squared, you divide it by the expected. So we've already done that. Maybe just to save us some time, I'm going to pause and just rewrite everything here, solve the first one of here, and then I'm gonna let you complete everything here until you get us the grand total here. Or maybe I'll just write it as our x stat chi-square stat. So chi-square stat, we are going to write it here. Now let's just pause the video, let's write everything here, and it's gonna help us organize ourselves in order to do our calculations. Okay, so just as an example here, what I'll do for the first one, I'll take 36 minus this, and then I square the answer, and I have 29.16. Then I'm going to write it there, And what I'll do, I take this 29.16, I divide it again by 30.6, which is going to give me 0.953. Now let's pause the video, and then I want you to do the remaining one and give me the grand total here with 3 decimal places. Okay. Alright, so this is the chi-square stat that we found. Our next step then will be to move to our fourth step, step 4. I'll just make space for it here. Step 4, and compare this to our critical. If you remember, our chi-square quit was 4.605. Now let's look at this, and we will see that the chi-square, the sample statistic, chi-square stat of 3.805 lies within the region of acceptance of the null hypothesis, right? So what does this mean statistically? Is that we have enough sample evidence to accept the null hypothesis. Then for our management conclusion in step 5, what we can say is that we can conclude, so we have enough sample evidence to accept, or we don't have enough to reject this in order to accept the alternative hypothesis. This is what you would say. We can conclude then with 90% confidence that I'm just gonna write the proportion of LC, loyalty card customers per store, so this is per store, is the same across all 3 store locations.